Then there is industrial wastewater, which is spent after processing in your industry, in your plant. There are these discharge or byproducts which is wastewater from the process. So there are two very different things. Domestic wastewater is household wastewater. That means what the constituent is basically you have black water, which is what is in your flush, right? Flush, and which includes fecal matter and urine, right? Then you have the other wastewater from a household or a commercial building or whatever institutional building, which is your washing of your hands and your showering, cooking, cleaning of your pots and pans and plates and that sort of thing. Clothes washing, all laundry, all of these constitutes another part of the wastewater. Another part. The more polluting one is what you flush. That contains high amounts of organic matter and also bacteria, pathogenic bacteria, which are health, basically promote health diseases and so forth if they are not handled properly. While the other wash your hands and all that, bathing and clothes washing and all are not as contaminated as your flush water. So there are two main streams from a domestic house or a commercial building or an institutional building. So these have to be treated before it is discharged to the environment, right? Because essentially the organic matter, when it is discharged, bacteria act on it. And when the bacteria consumes it, in most cases, if you discharge to a stream, it uses up the oxygen in the stream. It needs oxygen to degrade the organic matter. So then the stream becomes depleted of oxygen. So there are consequences for that, because if there's fish life or aquatic life in the river, then it's not enough for them to survive. So that's why you have to treat. The other thing that you have to treat is because when you discharge, you're discharging pathogenic bacteria, so that can cause illnesses if people downstream consume that water. So you have to cater for that also before you discharge it to the environment. So there are various ways to treat wastewater. It can be partially treated, fully treated. For example, a lot of houses in PJ, for example, have a septic tanks. But septic tanks is not a complete treatment. It's only a partial treatment. And it's discharged to surface drains and so forth, which then goes to the river. But it contains a lot of bacteria, pathogenic bacteria, and the level of organic matter is still high. It doesn't degrade much. So you need more sophisticated treatment systems to enable a safe discharge to the environment. So how do you do this? Basically, the septic tanks, there are different types of systems to handle the sewage. One is within your property. So within your property, you have a septic tank, or you can have a mechanized treatment plant, very small one. But in that case, you have to operate and maintain it. You have to build it and you have to operate and maintain it.
Will it be costly to handle?
For a house, your septic tank may cost you about $6,000 to $8,000. Right? But the problem is that as a householder, owner of a house, you're not interested to maintain and operate.
That's true.
Right? So then it malfunctions after some time because the sludge builds up in the tank. And if you don't periodically remove the sludge, which the service is provided by IWK or some other private contractors, then that sludge builds up and it overspills into the drain. So your polluting nature of the discharge becomes more and more as time goes on. So the normal rule is to discharge your tank once in 2 years, or once in 3 years at the maximum. So that is this on-site, what we call on-site treatment plant, which is within your compound, within the property. Then you have the centralized treatment plant, where discharges from several houses, condos, all that sort of thing are discharged to a sewer, what they call a pipe, underground pipe, which is laid on the public road, right? So that if you're within 30 meters of the sewer, by law you have to connect. You cannot have a individual system within your compound.
So that means everything that come from that home
Yeah.
will directly into the sewer.
Yeah, everything has to come into the sewer.
So
Yeah,
they,
in the past, before, they only took the flush water into the septic tank, while all the rest of the water went to the drain without treatment. But now it's a rule, a law, that all the wastewaters from a premise has to be discharged to a treatment plant within your site or to a sewer,
so
a
that-
public sewer.
So that means the house doesn't hold any septic tank at all.
Sorry?
I mean the treatment that Sir said based on the site.
Yeah.
So that means anything that came out from the house, for example like pieces that the person just
Yeah.
released,
Yeah.
will just straight away enter the sewer or will enter the septic tank first.
So if you have a sewer, you don't need to have a septic tank. So to answer your question is, if you have a septic tank, all goes straight into the septic tank, and then it discharges to the drain after some time. Normally, after 1 day detention in the septic tank. But if you have a sewer, you discharge directly to the sewer. You don't have to have a separate tank. Just straight into the sewer. And that sewer will take it to what they call is a central treatment plant, where it is like an industrial facility which receives the raw material is the sewage, right? Then it treats it to meet regulatory standards of discharge. And the Department of Environment has said that, as stipulated by law, that discharge to inland waters in Malaysia has to conform with these standards. That means the level of pollutants are described, limits of level of pollutants. So that means the raw sewage that goes into a treatment plant has say high levels of organic matter, right? High levels of ammonia, right? Ammonia, nitrogen, so forth, oil and grease, and so forth. So all of these have to be treated in order to meet the legislative standards of discharge. So you design your process, treatment process, in order to meet this defining mandate, that is to comply with the Department of Environment discharge, effluent discharge standards. So there, DOE has set different effluent discharge standards for sewage, for industrial waste. They're different. So they've got a number of different discharge standards for different types of wastewater.
So like usually the sites that Sir handle, what is the parameter that are needed to be monitored?
The main ones are total suspended solids, biochemical oxygen demand, which is organic, chemical oxygen demand, which is also reflective of organic, ammonical nitrogen, total nitrogen, in some cases phosphorus, oil and grease. These are the main parameters. But there are of course other things like heavy metals and all that in sewage, but the concentration is very low. So you know, although they have stipulated standards for that, but they do not monitor that rigorously. Once in a way, maybe twice a year, you may have to do the whole test. They give you a whole list of parameters, 15 parameters that you have to conform to, pollutants that you have to conform to. But normally for frequent monitoring is just about 6 or 7 parameters, which I have told you. And surprisingly, only recently they have also now come in and enforce bacterial control in the discharge. So the level of bacterial organisms you can have in a discharge is also regulated to a certain extent. And there are the standards, but there are 2 types of standards for each effluent discharge. The standard is tailored to, are you upstream or downstream? Your discharge point is upstream or downstream of a raw water intake point. You know, public water supply, you take in raw water, if you discharge to a stream, if you are discharging upstream of the water intake point, it's a more stringent regulation. What they call it a standard A regulation. If you discharge below any water intake facilities, then it is considered a standard B or less stringent.
What's the difference between these 2 standards?
In the level of level limits of pollutants that you can discharge. Say for example, BOD, you're familiar with it, huh? BOD for a standard A will be 30, maybe touched by about 30 milligrams per liter. While for a standard B it may be 50 or 70 or something like that. So it's less stringent. But the main thing is you have to design your process to treat your raw sewage to conform with the DOE discharge requirement. So that is the main thing. The black box is your treatment plant. How you design it in order that you meet your standards of discharge. That's the main principle of wastewater treatment. So for industrial wastewater, there's also different discharge standards, and then the pollutant parameters may be different from sewage. Industrial may not have more organic, except for maybe the canteen or whatever it is, the toilets and all will have similar properties as the, but the processed water volume is much higher than the sewage volume from an industrial facility. So the dilution factor is there. But what is more concerned about industrial is the heavy metals, cyanide, that sort of thing, you know. And also things like solvents and that sort of thing. So basically, but certain industries like breweries, food preparation industries, they will mimic the sewage to a certain extent, but their organic levels are much higher than sewage. Like sewage is about, BOD is around 225, 230 milligrams per liter. A food processing plant may have a BOD around 1,000 or even things. So you have to cater for these different types of raw wastewater discharges. You design your treatment plant to cater for these levels coming in to meet the DOE discharge levels. So that is the main principle of the wastewater discharge. So now I will now stop for a while. Maybe you want to ask some questions, but things that I may not have touched that you want to ask.
What are the safety measures? Number 6.
Yeah.
Safety measure using during water treatment process.
This is to a wastewater treatment process. What are the safety measures? Safety measures, you have heard of IWK, right? In the water consortium. In the water consortium. So they are very concerned about safety in treatment plants. So the treatment plant mainly open tanks, most probably open tanks. So safety things like handrails, you have to be put in there, right? And then sometimes when it is basically like if you have pump stations, you pump the liquid, you may have to go below ground. So then, because sewage that comes in, methane, they release methane gas to a certain extent. Yeah. depending on how the substitute, how long it has been in the sewer before it comes in. Because in the sewer itself, there will be some degradation mechanisms operating. So that will release some toxic gases, hydrogen sulfide, methane gas. So this will accumulate in the pump station is normally deep underground. So you need ventilation. Otherwise, if you go down there and you breathe in this, you may conk out or even die after if the concentration is very high. So those safety things, so you have to ventilate those underground chambers basically. But then the other thing, of course, is you have what are the safety measures? Ventilation is one, guardrails is another one, and also you need blowers. You have blowers, compressors that supply air for the system, for the treatment plant, and aerators, mechanical aerators that churn up the water so that oxygen can come in. So these sort of things you have to handle it carefully, the blowers and the mechanical system. You have to be aware that how to operate that, so that you don't suddenly turn on a blower while you're there maintaining it, something like that. So there are safeguards for how you can maintain the blowers and mechanical equipment, and also electrical equipment. You have a lot in the treatment plant depends on electricity to a great deal to power the systems, the mechanical systems. So here again, the electrical, how you handle the electrical system is also important. Safeguards to you don't get electrocuted or whatever it is. So there are certain safeguards to be implemented to ensure that the operator doesn't accidentally get shocks or something like that. So these are the major safety, some of the safety things, and of course you will have maintenance trucks coming in and going out, so that the safety within the plant itself, workers going around and the vehicles coming in and going. So those sort of safety things have to be there to regulate the traffic flow in the plant itself. And lifting equipment, so you have to have the necessary cranes or whatever lifting equipments to take out the equipment from the basin and then maintain it and then put it back again. So again, these are some of the things that you have to be careful about. But most things is the gases that are released sometimes in underground systems. Not right. So you have to ventilate that and make sure the workers are not subjected to toxic gases. That's something. So you have to. So before you go in, you start your ventilation system. Draw off the toxic gases before you go in on that basis. So because some gases remain in the floor level, other gases will rise to the top. So that means you have to design your ventilation system that you take this out somewhere. So where the suction pipes are placed and all that has to be determined based on this one. Because I think like hydrogen sulfide will rise to the top. So then you have to take it out from there. Methane might not go up there, it might stay at the lower level. So you have to have a draw off at the lower levels. That's something. So those are basically the safety measures, your electrical system, ventilation, sorry?
Lifting equipment.
Lifting equipment, all that. You have to be. That's why when you design a treatment plant, they do what you call it, I can't remember, they do a run to see what are the accidents that can happen.
Test run, is it?
No, this is a study. A study on what accidents can probably happen during the operation of a plant. And so then they say all the different scenarios they will come up with and say, how do we tackle this? So before even you start operating, you have all these systems in place so that you know that what are the incidents, probability of incidents can happen, what type of incidents, and how do you tackle that to maintain safety of the plant operators. Well, but that's the operation side. Construction side, there's different safety aspects. I mean, general construction safety aspects you have to design. Because you're having a lot of concrete, you put in excavation, all that sort of thing that you have the normal safety measures that you apply on construction practices will also apply here. So, and the other thing is that is a treatment plant, but sewers you may have to maintain from time to time. So basically sometimes it's a blockage or something like that, you may have to go in and try and remove the, if it's a bigger pipe, you can go and remove it. Or if the pipe itself deteriorates, then you have to refit the lining. So then you have to have, basically measures to maintain the safety of the worker who may have to go in. So those are the sewer part. So normally in the sewage system, you have the collection from the premise, then you have the sewer, then you have also a pump station, because sewers are all gravity. So they are laid at a gradient. So the longer the sewer pipe, the deeper it becomes at the end. So then you have to lift it up to the treatment plant which is on the surface. So you have the pump stations. Then you have the treatment plant. And then it flows out into the river. So these are some of the safety aspects that we will consider in
And when the wastewater that reach to the treatment plant, right? What kind of treatment are you using? Aerobic or anaerobic?
You can use both, depending, but normally it would be aerobic systems applied because it's faster. It's faster, the less volume is required, right? But certain thing, it depends on the strength of the wastewater. Sometimes if the strength is very high, then they use anaerobic.
Means of strength is
The BOD concentration. Say, like if you have 1,000 or something like that, then maybe it's more feasible, economical to do anaerobic digestion first and then go to aerobic to polish it off. But of course, when you look at a treatment plant, nowadays it's environmental dimension comes in. Essentially, how do you you see, sewage is considered waste, but it's still a resource to a certain extent. Because you can take sewage, you can ferment it or anaerobically digest it, you can produce methane gas. That methane gas can be combusted to produce heat, which drives a steam engine or whatever it is, and it produces electricity. So now the basis is try and see if the size of the plant is to a certain degree, level, then you can extract. See, what happens is sewage, as I told you, is basically dissolved pollutants as well as suspended solids. Now that suspended solids normally is settled first, removed from the liquid portion. The liquid portion is treated aerobically. The settled portion contains a lot of organic matter, where you can extract methane gas from that to generate electricity. So normally in a big plant, a small plant may not be feasible. In a big plant, they normally settle the solids, use the solids, digest it anaerobically, generate gas, and supply internal demands for electricity. Or in other countries, they sell it to the national grid during off-peak hours, so that they can get revenue from that. Because now any system where you sell to the electricity, there's a feed-in tariff which they give you. If you sell a certain amount of electricity, you get a certain amount of revenue from the government, from TNB. So this is making use of the resource, because the solids ultimately have to be disposed somewhere. So that is a big problem that they are facing, because the landfills may not want to accept it. So how do you, there is a big problem of sewage treatment, how you dispose your sludge. So basically what they do is that, the other digest it. so that the volume is reduced, the mass is reduced because you produce gas, and so the solids that remain are less in quantity. So that one, maybe you can. Now they do it is bury in trenches, or they go to some landfill operators will accept it at a higher cost to this one. So that is a big problem now they are facing on how to, because massive amounts, if you look at all the total amount of population that is being treated, sewage treated from population, it's a big amount with daily generation, so they have to have some way of disposing them. So that's the currently now lah. In overseas, they may use it as fertilizer. They may, essentially take the sludge, reduce the water content, kill off the harmful bacteria, and then they sell it to farmers who farm that, who put it as a soil conditioner and a nutrient for the plants. So these are some of the things that that are being thought of now, how to recover resources in the waste itself.
Because from what I know, what is sludge is basically consists of mud and
Solid,
some
solid.
solid
Yeah.
kind of feces and so
Yeah.
on that is unable to be digested in aeration process.
The aeration process is more difficult. I mean, aeration process is more solid, dissolved solids, dissolved, that they can more efficient to deal with. While the suspended solids, they can, but it's oxygen consumed because a lot of energy is required. Because to get the air, to blow the air through, a lot of energy is required. So you need to process that one, and ultimately also from an aerobic system, you get sludge coming out. You get sludge coming out. Any treatment plant in the treating sewage, you have the problem of sludge. Whether it's aerobic or anaerobic or whatever it is, you have the sludge problem, which you have to deal with.
So now the sludge that are produced are often, like, how do you treat it? The sludge?
Basically, the way to treat it is like anaerobic digestion, where that's one order of it. The other one is you can burn it, you can incinerate it. That means you take the sludge, you dewater it to a sufficiently hard, spadable solid mesh. Then you put it into an incinerator because it's organic matter there still. So the organic matter will burn, and so that is one way of destroying. Then whatever you get is ash. That's all, which is inert. But that's very expensive, lah. The way you have to dewater it is another one expense. Then you go and you have to combust it, which is you need fuels and all that stuff to generate the heat, which is very expensive. So they rather not do that.
Can you share some experience what you have applied?
Sorry?
Number 9.
Number 9, huh? Where you apply
New
type of
technology or information?
Where you use new type of technology or information in your job. How did it help your company? Okay, I mean now basically one of the things that land is a premium in this country.
Premium?
Is a premium, a high cost,
Oh,
right?
yeah.
So normally the sewage is generated in the urban areas, right? So then you have to find land within this urban area to accommodate your sewage treatment plant. And sewage treatment plants can be quite, depending on the volume that you have to treat, quite a big area is required, and it's very high cost to procure it. So now there are ways now of trying to reduce the footprint size of your treatment plant. And one of the ways is to use membrane technology. Membrane technology is basically like, in Singapore, New Water, have you heard of New Water?
Yes.
They use these membrane systems in order to take out all the pollutants and you can clean what you can drink it, basically. It's only the psychological barrier that is there. But you can have a membrane system that can remove all of your pollutants, and you can then reconsume it now, recirculate it back into your public water supply system. But they in Singapore mainly they use for industrial water systems. So this is another thing. Now we are in our company trying to see how we can adapt the membrane technology to make the treatment plant more efficient, less land use requirements. So these are new technologies that we are adapting rather than the conventional ones. That's one the main idea is to reduce the footprint size and to improve the efficiency of discharge, pollutant discharge. Because as time goes on, level of pollutants that can be discharged will be increasingly more stringent. So you have to cater for that in the future. Because as rivers, our rivers are not very, actually in the East Coast, the West Coast especially, where more of the population is, the rivers are not very big and voluminous. So it gets contaminated quite easily. So the level of, the level of pollutants that you can afford to discharge to these rivers without impacting on their resource value will get more stringent as time goes on. So like membrane technology is one of the things now that is membrane technology is used, seawater, desalination of seawater. Some of the Middle East countries use that extensively to get public water supply, but it's very high cost. But the same principle is applied here on a smaller scale to sewage treatment. So now we are embarking on that process to see how to make affordability is the thing now. How we can apply this new membrane technology in order to enhance our capability of reducing the overall cost now. If you take land cost also into consideration, then the whole treatment plant cost, you have to cater for that, or land as also, so reduce the land size for your treatment plant. So this is what we are doing now at the present moment, trying to see how best the economics of it, trying to evaluate the economics of it. Because now membrane technology, those days was very high cost. Now it's coming very low over time. It's coming low. So it's more economical to apply it nowadays. So we are looking into that.
Okay, let's say if membrane technology is in Malaysia, right?
Yeah.
What are you gonna do? In Shah Alam, in PJ?
No, now in Putrajaya they're using membrane technology.
Oh, it's already
It's
started.
a pilot plant lah. Okay. So basically, as time goes on, people are more now concentrating on that, trying to see how feasible it is in order to apply this system. Because land is a big problem also to society. Otherwise, you have to go miles out into your countryside and have your treatment plant there, but then the cost of laying the sewers up to that point is very exorbitant. So these are the things that so there's not only the technical part, the economic part also you have to handle on these options that you have. How do you select the best option?
Do you have any layout of the plan that you're consulting for? Can we have a look?
Layout. Unfortunately, you see what has happened now is we were dealing with that before, but now another division is dealing with it. So most of our these things have gone over that side. I can't, unfortunately, I can't.
It's okay.
Give it.
You have a question?
Ricky?
Okay. So hopefully I can, offhand I could explain to you. But these are the main fundamentals. But you are more concentrated on safety, right?
And wastewater
Yes.
also.
Huh? Wastewater. You are doing wastewater also.
No, our subject. No.
Because safety, it's quite wide.
Diagram.